Welcome to Chemistry Today. Today we're going to be wrapping up our gas unit, and we're going to be discussing this new law called the ideal gas law, which will be the last law in the long line of gas laws that we've studied in class. Okay? So what is the ideal gas law? It's a combination of Boyle's law, Charles's law, and Avogadro's law. So we're dealing with pressure, volume, temperature, and the number of moles of a gas. So how is it expressed? PV equals nRT. With the variables given here, P is pressure in ATMs, V is volume in liters, and N is the number of moles of a gas. R is this new term. R is this term that's called the ideal gas constant, and we're going to actually solve for that constant during this session today. And T, finally, is temperature given in kelvins. My Kelvin's got smudged here. Kelvin. I don't think that does any Kelvin. Okay. So what is an ideal gas? An ideal gas is going to is going to behave in a very predictable way. Its pressure, volume, and temperature is going to be described by this ideal gas. Right? But be mindful, there's no gas that's really ideal. We can make predictions of how gases are going to behave under certain conditions. Okay? So real gases, they deviate from the ideal gas behavior. If they're under immense pressure, typically greater than 1 atm, or if gases are at low temperatures, they have a tendency not to behave ideally, meaning they have a tendency to bond with each other, because if they slow down due to low temperatures or have more collisions due to high pressures, there's going to be some intermolecular bonding going on, which will slow these gas particles down, and they will not be behaving ideally. Right? Gases ideally should not have collisions that cause them to bond. They should be totally elastic collisions where two gas particles hit each other, bounce off of each other without any bonding occurring. Okay. So what is this value of R, this gas constant? So what I've done to calculate for R, I'm going to solve for R using standard temperature and pressure conditions, STP. So our standard pressure is 1 atm. Our standard temperature is 273.15 Kelvin. With 1 mole, under these conditions, according to Avogadro, a mole of a gas will occupy 22.4 liters. Right? So I'm simply going to transpose for R and solve for R under these conditions. So by doing so, the next slide, there we go. All right. So you got to watch your slides falling on you. So R is isolated, right? So I plug in for P, 1 atm, and my volume is 22.4 liters. My number of moles is 1, and my temperature is 273.15. So we get this numerical value of 0.0821. This is the number, this is the value that we're going to use for R. It's a constant. And also notice that my 4 units here, ATM, liter, mole, and K, they never cancel each other out. So the ideal gas constant actually has 4 units attached to it, ATM, liter, per mole, K. In our next video, I'm going to give you a problem or two using the ideal gas constant in the ideal gas equation to solve for.